So chapter 5 starts out, we're going to end up, the reason chapter 5 is difficult is because not only are we going to differentiate, we are also going to integrate, and then we're going to throw a whole bunch of natural logs, common logs, logs with other bases, different types of integration, and it just seems to come really fast and really quick. 5.1 addresses the derivative of a natural log. So if you look at number 9 on your little sheet, look, here's number 9. If you are given a natural log, the method of differentiation is you take the derivative of the argument and then write it over the argument itself. That is the method of differentiation. What makes it difficult sometimes is if that argument is nasty. And if that's the case, then what we can do is go in and use rules of logarithms to make it easier to differentiate. Okay, so I'm going to show you 2 different ways on number 1. So number 1 says I've got the natural log of 4x. Okay, so if I want to take the derivative of the natural log of 4x, what I can do is take the derivative of the argument. The argument is 4x. So what's the derivative of 4x? It is 4. Over the argument itself. Well, what's the argument? It's 4x. And you'll notice that your 4's reduce out. And so this thing actually simplifies down to 1 over x. Okay, so that's your answer, is 1 over x. Well, what I could have done was rules of logarithms first. So if it's multiplication on the inside, I can separate it out to 2 separate logs. So I'll have the log of 4, the natural log of 4 plus the natural log of x. Well, the natural log of 4 is a number. So his derivative is 0. And then what's the derivative of the natural log of x? It's the derivative of the argument, which is 1, over the argument itself, which is x. Okay, so you end up with the same answer. Okay, so sometimes rules of logarithms will make things easier. So we'll kind of sort of talk about that as we go through. All right, so for number 2, I want to find the derivative of, so f of x equals, and I've got a 6x squared times the natural log of 6x. So 6x squared times the natural log of 6x. And if you will look, you have multiplication. Okay, so I'm going to have to use product rule. And then in the process of using product rule, I'm going to have to use our new differentiation of a natural log. So for product rule, I've got the first, which is 6x squared, times the derivative of the second. So the derivative of a natural log is the derivative of the argument over the argument itself, plus the second, which is the natural log of 6x, times the derivative of the first, which is a 12x. So these 6's reduce, and then this x will kill off one of those x's. So that goes away, and that goes away. So your cleaned up first derivative is 6x plus 12x times the natural log of 6x. Okay? All right, let's do another one. So we have f of x equals the natural log of x times the square root of x squared minus 9. All right, so if we're just going to leave this in log world, what I would do is the derivative of the argument, which is going to require product rule and chain rule, over the argument itself. Or I can apply rules of logarithms first. And that's going to be easier as far as differentiation goes. You'll get the same answer, it'll just look completely different. So if I rewrite this, I'll have the natural log of x plus, because if it's multiplication on the inside, it's addition on the outside. Remember that this is an exponent of 1/2, and I can drop an exponent down out front as a coefficient. So 1/2 x squared minus 9. Okay, so all I've done is algebra. I have not done any calculus yet. So now this argument is awfully easy to deal with, and so is this one. So I just did a little bit of algebra up front to make the calculus easier. So if I take a derivative of a natural log of x, the derivative of the argument over the argument itself, plus 1/2 is going to come along for the ride. And then the derivative of the argument is 2x over the argument itself, which is x squared minus 9. And then the 1/2 and the 2 reduce. So your completed derivative is 1 over x plus x over x squared minus 9. And that just makes it a whole lot cleaner to take those derivatives. So let's do another one. We have 4x. Hang on, I don't know what we have. That was a lie. The natural log of 8x over x plus 1. Sorry, that's a big fat argument. All right, so I can separate this out. If it's division on the inside, then it's subtraction on the outside. But remember, if you want to, because I've done it twice now, that coefficient is going to reduce out. That coefficient reduced out, which means you should recognize that coefficient is going to reduce out. So if I rewrite this, what I have technically is the natural log of 8 plus the natural log of x minus the natural log of x plus 1. So it's multiplication on the inside, so it's addition on the outside. It's division on the inside, so it's subtraction on the outside. So all I've done is algebra. Well, now that makes it extremely easy for me to take a derivative. So the derivative of the argument is 0 over 8, so that goes away. The derivative of x is 1 over the argument itself, and then minus the derivative of x plus 1 over the argument itself. And now you're done. We've differentiated. So let's do a few more. We have the natural log of, the natural log of the square root of x plus 1 over x minus 1. Okay, so again, if I were to just leave it this way and start taking derivatives, I would have to do quotient rule, chain rule, power rule, all this kind of stuff all over this mess. So it's messy. So the first thing I'm going to do is rewrite my square root as a 1/2 and then drop it out front. Okay, so this now says, without me doing any calculus, I've got 1/2 times the natural log of x plus 1 over x minus 1. And now if it's division on the inside, it's subtraction on the outside. Be careful, because that 1/2 belongs to everything you do. So I have y equals 1/2 times the natural log of x plus 1 minus 1/2 times the natural log of x minus 1. And now I can take a derivative. So y prime, now if you wanted to, you could have just put the 1/2 out front and put this thing in parentheses and just done it that way and have the 1/2 come along for the ride. Same thing. Okay. So what I have is 1/2 and then the derivative of the argument over the argument itself minus 1/2 derivative of the argument over the argument itself. And then you're done. Okay. Let's do some more. Oop, that was that one. Hang on. All right, so we've got another similar one. So y equals the natural log of the 6th root of x minus 7, x plus 7. Okay, so first thing I want to do is get rid of that 6th root, and I'm going to use it as a 1/6. And then because I'm in log world, I'm allowed to drop that out front as a coefficient. So this thing cleaned up now says 1/6 times the natural log of x minus 7 over x plus 7. All right, so on this one, I carried along the 1/2 for each term. On this one, I'm just going to pull the 1/6 out front so you can see better what I was talking about. So this thing's derivative is 1/6. Actually, I'm not doing a derivative yet, sorry. All right, so 1/6 times everything that I do. So the natural log of x minus 7 minus the natural log of x plus 7. And now I'm going to take a derivative. Sorry. So in this one up here, I gave the 1/2 to every term. Down here, I'm just going to pull it out front for the ride. Again, same thing, it just looks different. So my derivative is 1/6 is a constant multiple that comes along for the ride. And then the derivative of natural log is the derivative of the argument over the argument itself minus the derivative of the argument over the argument itself. And so if you'll notice, this one I could have factored out a 1/2. Okay. On this one, I just left it in factored form. Same thing, it just looks different. So either one is appropriate. All right, so let's do another couple. I've got a few more minutes. All right, so I've got number 7 says the natural log, hang on, y equals, sorry, the natural log of x plus, and then I've got 9 plus x squared. Okay, I can't break this out. This is stuck because if the argument is joined by addition, I'm trapped. Okay, so this one is just going to be flat out ugly. So my derivative is going to be the derivative of the argument. Okay, so the argument's derivative is going to be 1. And then I'm going to rewrite this one for a second. That gives me a 9 plus x to, x squared to the 1/2 power. So I am not in log world right now. I'm just dealing with the argument. So this derivative is 1/2, drop your exponent out front, 9 plus x squared to the negative 1/2 times the derivative of the inside, which is 2x. Okay, so this is this derivative plus this derivative, and then over the argument itself. And then that's your answer. Okay, it's ugly, but that's your answer. You can clean this up. This 1/2 and this 2 reduce out. And I kind of sort of messed that up. That's an x squared right there. But basically that's it. So if you can use log rules, you're going to want to use log rules to clean it up. All right, we got time for one more. So I've got y equals the natural log of the absolute value of sine x. Okay, so I would like to take that thing's derivative. So the derivative of a natural log is the derivative of the argument. Well, what's the derivative of sine? It is cosine. Over the argument itself, which is sine. Okay, well, what is cosine over sine? It is cotangent. Okay, so you can leave it like this, or simplified form is going to be this. Okay, and actually I can do one more. All right, so I've got y equals the natural log of cosecant 6x and then we've got absolute values going on because remember the argument of a log function can never be negative. So we were kind of sloppy at first. Technically, all of these should have been in absolute values. But for now, we're just kind of solidifying that. So your argument is just absolute value. So for this one, what is the derivative of cosecant? Well, remember, we're going to have to do chain rule on this. So how do I take the derivative of a natural log? I take the derivative of the argument. So what's the derivative of cosecant? Derivative of cosecant is negative cosecant cotangent times the derivative of the inside, which is 6. Okay, over the argument itself, which is cosecant 6x. So that actually reduces out. Okay, and you're left with a negative 6 cotangent 6x. And that is all I'm going to have time for, but we're almost done. So the next video will just have the last few.